Okay, so let's move on and let's go to the next, right? So let's understand this, right? So you have customer A, right? Customer A, we can consider this as Arista, right? And this is customer B, any other customer, right? Let's say XYZ, XYZ. Okay. Now both has this 10.1.00 subnet here. You can consider this as Bangalore office location, and this is San Francisco. Okay. And so you have 10.1.00 private subnet, right? You want, what you want is you want to communicate between this 10.1.00 to 10.000, this subnet, which is at HQ, right? Arista HQ office. So you want to communicate that between these two hosts. And for that, what you need is you need to learn this route 10.0.0.0 through ISP. Through this is your ISP network, right? And you should run this route 10.0.0.0 through ISP, saying that, hey, whatever packet I want to send to 10.0.0.0, I have to send it to the ISP, and ISP then take care of it, will take care of it. Similarly, I have to advertise this prefix to this side right here, correct? So that both knows each other how to reach the other subnet. Similar for this another, company, right? Now, what should we do? Because if you see here, right, on this P2 device, right, where both the customers are connected, we end up receiving same subnet, right? 10.1.00/24, correct? So how should we solve the problem? Because when packet comes for 10.1.00, right, destined to, even if that packet comes from Arista, you might send it to this XYZ, right? Because you have this route also receiving from this company or customer. So what should we do?
Route distinguisher and VRFs.
Okay, so yeah, we'll come to RD, route distinguisher, next. But what you mentioned is VRF, right? VRF, correct? So
Yes.
let's say this is PE2, correct? PE2 device, right? What is VRF? Anybody can tell me what is VRF?
It's a segregation of a routing table.
Okay, yeah. So basically VRF is virtual route forwarder, which is nothing but, let's say this is your basically your router, right? You are dividing this router into multiple parts, right? As far as routing table is concerned. So basically, so it is you can consider it as a virtual division, right? Where the customer B, right? Customer B, whatever route you receive here, that is 10.1.0.0/24, that will be stored in this routing table, this VRF routing table, VRF. So this we can say VRF customer B, right? Customer B VRF, customer B VRF. Similarly, this is customer A VRF, right? There, whatever route we receive here, that will be stored here in this customer A route VRF. So basically, this is independent routing table, right? They are not combined with each other. So that's how you are able to manage both the routes separately, even though you are receiving these routes on same hardware device, right? So by using VRF, virtual router forwarding, you can create different routing tables. That is one for customer B and one for customer A, which is unique. And both are not, basically they both will not interrelate with each other, right? They will not, unless you do route leaking between WAF, right? So this is called VRF concept, right? Where you divide your router into multiple different WAF. Okay, any question on this? Okay, Now let's understand what if I don't have this facility VRF, right, on this router. What should we do to accomplish this, right? So what I want to do is I want to advertise this subnet to this guy here, and also this subnet to this guy here, but they should not, get exchanged. Basically, it should not happen that packet from Arista goes to XYZ, right? How we can do without VRF? We need to place different separate router, right? Separate router for each customer. So if you have ISP and you have hundreds of customer, you need to use different router for each customer to keep this routes isolated, right? Which is not feasible. And that's why the concept of VRF comes into place, where you can have single router or switch, but you have different unique routing tables for each WAF, right? So that's how this is useful. Now let's understand this, right? So we solve one purpose, right? One issue where we are able to separate these routes, both route from each other, right? So this is customer B and this is customer A, and we have both the routes here, right? Now another challenge is, so we have here, two WAF and two routing table. Now another challenge is we want to advertise this route only to this guy, right? A to A and B to B, right? How we will achieve this? See, there are in between many devices, right? So what should we do so that this particular route only goes out here?
Have local VRFs on each devices or
Yes, right? Yes. So that is first solution, right? So what you have to do is on all these devices, right? There are hundreds, thousands of intermediate devices in ISP network. What you have to do is, this is A WAF, right? And this is A. So again, on P1 also you have to create same different WAF, and you need to have, BGP or whatever, right? Neighborship, where you exchange this route in this WAF A to here, and exchange this route in WAF B to this routing WAF, right? And again, similarly here also you have WAF A and WAF B, right? And you exchange this here and here, right? So basically, and this is just, we are talking about two customer. If you have hundreds or thousand customer, right, and that is obviously ISP will have, right? Is it feasible to maintain this many of BGP connection across all the devices, and also thousands of WAF on all the devices, right? Is it possible? And thousands of BGP neighborship for each WAF, right, across the network backbone. Is it possible or feasible?
No, not scalable.
Not scalable, right? And it's also very difficult to troubleshoot, right? Means you have, it's so much confusing, right? And one more thing, let's say, even though we do implement this, what if, this customer B also wants to receive this route from customer A, not this subnet, but some another subnet, 10.10.00, right? Something like this, which this guy also wants to receive. Let's say this is, big switch, BSN. We acquired it right now, right? And now we want to advertise some of the prefixes to BSN as well, or some of the BSN prefixes we want to receive here, right? Is it all feasible? We have to do then route linking and all that stuff, right? And then WAF. So basically it's not scalable, right? Agree? Any question on this? Okay. So basically we understood that, yeah, WRF is definitely needed, right? We should have WRF so that we can separate this different routes, same route, but different customer routes. But to scale, it's not possible that all intermediate devices will have WRF, right? Separate WRF or separate routing table for each customer. So what is the solution? So that is the so that's where we come, the concept of RD and RT comes into place. RD means route distinguisher, right? And RT is route target. Okay. So let's understand first route distinguisher, RD, right? So basically what we are doing is we are receiving this prefix here, right? So this is my switch. Okay. This P2, and this is my WAF B routing table, and this is A routing table. What I'll receive this route from customer B, so I will place that into my routing table, WAF B routing table, right? 10.1.0.0/24. Similarly, the same is placed here as we receive this from here, right? 10.1.0.0/24. Okay. Now what we do is we add, so this is 32 bits prefix, right? IP address 32 bits, right? We add route distinguisher RD, right? RD, which is 64 bits. Okay. And there are different, this possible, you means you can choose any of this method to, configure route distinguisher. You can use router ID combination with WARF ID, loopback ID, 2VNI, or ASN to 224 byte, right? Or even we can use 1:1. So let's say you choose 1:1 for customer A. So this is 1:1, right? For customer A, right? RD. And this is 2:2 for customer B. Now what we do is we combine this route distinguisher 64 bit, right, with the prefix 32 bit, right? 32 bit. So in total it will be 96 bits, right? Which is called VPN v4 route. VPN v4 route. So combination of RD plus IP prefix, which is 96 bits, is called VPN v4 route. Okay. So now, and this route will be installed in EVPN global table, right? So EVPN global table. Okay. So when we combine this with 1:1, so overall route will be 1:1, right? :1, whatever, 10.1.0.0/24. So this will be imported or will be in EVPN global table, right? Another route is 2.2:2, again 10.1.0.0/24. Okay. So basically now if you see EVPN table, right, global table, you have two separate route, right? Which was same 10.1.0.0, both are same, but because you added RD route distinguisher, now both routes are separate, different, right? And you can easily identify which one is for what, right? So by adding route distinguisher, we can separate or make each route unique within the global table, EVPN global table, right? So there are different tables, right? Routing table on P, one is WARF table, WARF for customer B, one for 1A, WARF for routing table for customer A. We will also have default WARF routing table, right? Default routing table, right? So that is also their default routing table, and then EVPN table, global table, where we will put this routes into this. Okay. Is it clear? Any question? As far as RD is concerned, why RD? Okay. Now let's understand how this is helping us, right? What P1 will have, what type of routes P1 will have. Still we need different WARF for each WARF routing table on P1, or we can have this, or it's not needed.
It's not needed now. There are
Okay.
different routes.
Yes. So now this routes, right? This unique routes, VPN v4 routes, is what will be advertised to the P1 or any other router in the backbone, right? So all these devices in between, right, will have only this VPN v4 routing table global, right? They will not have any WAF, different WAFs. So you don't have to create this different WAFs on all these backbone devices. You will just have global EVPN table. Obviously default routing table will always be there, but other than that, you don't have to create this different WAF routing table, right? Now you send this route, EVPN routes, right? Both are VPN v4 route, which is this and this, to P1. P1 will advertise it to P2, and finally it will advertise to PE1, right? This device. Now again, as this is a PE device, customer edge device, right? This will again have multiple WAF. That depends with which customer it is connected. That WAF it will have, right? It will also have same this type of table like this P2, where you will install this whatever routes it is receiving from P devices. This will be installed in its EVPN routing table global, and based on that, based on route target, it will install this particular route into the routing table of that WAF. We'll discuss that, right? How that will happen. But basically, the point here is, have you understood the why we need to add RD? And because of that, we are able to create unique EVPN route, and that is advertised across the backbone, and to at the finally it reaches to the PE1, right? VPN v4 routes. Any question on this? Why we need RD and how it's solving the purpose? Okay. Okay, so I think if this is clear, then let's move on, right? So now there is another concept of route target. So we understood, right? We use route distinguisher, right? Add route distinguisher and to make each route unique, right? VPN v4 route, and then that route will be advertised across the network, right? Now we received this route here, right? Both the routes, VPN v4 route, which is this one and this one, we received on PE1 on global EVPN table. So here we have 1:1 and 2:2. Two routes are there, right? On global EVPN table. Now we have also customer A WAF and customer B WAF, right? Now, how we will know that, which route I have to import into which WAF, right? I have to do reverse, right? I have to import this route into particular WAF, right? How I will know, right? So that's why we need route target, okay? So what we do is, we use one route target. So when you advertise this route, right, from here to this guy P1, again we will also have two types of so basically this is the configuration, EVPN configuration, right? So for work customer A, under router BGP, all the neighborship configuration. After that we will have WRF customer A. Route distinguisher we are going to use for this customer A WAF is 1:1 and 2:2 for customer B. Route target we are going to use as 100:100 for import, and export is also 100:100. Okay. And similarly for customer B, it's 200:200, right? Now let's see. So this is the configuration. Now what will happen? So you receive this 10.1.00 route here in this WAF, customer B WAF. Similarly, you receive the same and customer A WAF. Okay, 10.1.00. Now what you do is you check the configuration in customer A WAF. You check the configuration that RD is 1:1. So what I will do is I'll add RD of 1:1 along with the route I have received in this customer A WAF, and I will create VPN v4 route, which will be installed into my global EVPN table. So this is in my global EVPN table. Similarly, on customer B VRF, I'll check the route distinguisher used RD22. So I'll combine this prefix with 2:2, create VPN v4 route, and again install it into the global EVPN table. So now we have two different unique route into global EVPN table, right? Now we want to advertise this both route to PE1 through this all P devices, right, in between. Now when I advertise this route to P1 device, right, this one, right, customer A route, what I add is I also add route target with this route. Okay, I'll show you how it will be reflected in update message, right, in packet capture. Okay, and how basically how this route target is added in packet capture, right? So we add route target. So with what is that route target? So we will check that, hey, what route target I have to add for customer A. So it is here in configuration route target export. We are exporting this route, right? So export is 100:100. So basically I will add 100:100. Okay. So now when this route is received here on P devices, it will have two information. One is VPN v4 route, right, which is RD plus prefix, right, 10.1.0.0, and it also will have route target associated with it. So this is the one routing information in routing table. Okay. Similarly, when you have to export the another route, right, advertise another route to P device, which is customer B, you have export route target of 200:200. So you will add here route target of 200:200. Okay. So again, here you will have 2:2 and this route, and route target is 200:200. Okay. Any question so far? If you have not understood. Okay. Now, finally, this route will be advertised to other PE device, and then finally it reaches the PE device, right? So now again, PE device has two routes. One is 1:1 route target 100:100, and another is to this one, right? To in EVPN global table. So this is the two routes in EVPN global table. Now it has to advertise this route, specific route, to the customer, right? And for that, it has to install that route into the VRF, that particular VRF, customer A and B, right? How it will understand that, hey, which route I have to install in which VRF, right? There are two routes. Which one I have to install in which VRF? So that's where this import. So same configuration also will be at the PE1 device, right? Same. So now it will check this two, right? Routing table in EVPN table. It checks that, hey, in VRF customer A routing table, which route I have to install? I have to install route which has route target of 100:100 import, right? So whatever route which I have to import the route with route target 100:100. So this route has route target 100:100, right? So it will install this particular route, which is 10.1.00/24 into VRF A, right? Similarly, this has route target 200:200. So that will be installed in VRF of customer B. Okay. And then from there, it will through BGP or any other protocol that will be advertised to customer, right? So basically, we have two things. One is route distinguisher and another is route target, right? Route distinguisher is 64-bit, which you add to the prefix to create VPN v4 route, right? It has only local significance, and then it will be advertised that VPN v4 route along with route target to the other P devices. Finally, it reaches to other end of PE devices. Route target is to install the route into the VRF. So based on route target information, you will decide this route I have to install in which VRF, right? So that's where route target comes into the place, right? Is useful. Okay. Any question? Are you clear with what is RD? What is the purpose of RD? And what is the purpose of RT? Or any question on this?
Here the P1 on the other side, it cannot just rely on the RD to install into the to basically advertise the routes that it receives, mainly because like customer B might intend to advertise routes to customer A.
Yes, that's right. And that was my next question, right? I was going to ask you guys that, hey, why we need separate RT, right? Why we need separate RT? Can't we achieve same thing through RD, right? So basically, let's say it this way, right? I just add RD, okay? Forget about route target. We don't, let's say we are not using route target, right? Why we need RT, right? So let's say I added this made unique routes, right? I advertise here and that came again here. And here I will install route, basically select route based on RD. So let's say I will say, hey, whatever route has RD11, it will be installed in this routing table. And whatever route has RD22, it will be installed in this VERF, right? My problem is solved, right? With only RD. Agree or not on this point? Right? Why we need RT then? Correct? Do you guys agree? Basically, this problem is solved, right? Okay. So that's where RT comes into place. As Rohit mentioned, let's say you have one requirement. See, this is very simple, right? One customer to another customer route advertisement, right? It's a very simple, basically topology or design. But what if, we both customers are, migrated or acquired by each other? Let's say this is Arista and this is BSN or Awake, right? And now there is a requirement that, hey, I want to advertise here. There is one another route. Let's say this customer has 10.10.0.0/24, correct? This is advertised here. Now there is requirement that, hey, this host in this subnet, right? In this subnet also wants to communicate with this server, this host, right? And basically, so basically you want to receive here 10.10.00 of customer B, right? Now tell me, with RD only, is it possible? Without RT, only with RD, is it possible?
We can't control the way which we want. We suppose if we don't want to combine the routes, we can't control it in that case.
Yes. See, the reason is, right, now let's say forget about RT, right? We don't have RT at one, let's say, right? Now you want to receive this. Now you based on RD only, you are taking decision which route to receive, install into this WAF, right? Now you want to install 10.10.00, right? Here as well, right? And for that, you have to allow this RD2:2 also here, right? So that RD22 also you want to install here, right? 1.1 definitely you want to install, but 2.2 also, right? Now, but what will happen when you configure 2 RD? Can you configure 2 RD on under one customer verb?
No.
No, right? Because you are using same thing to make the routes unique, right? If you have configured 2 RD, with which RD you will make this route unique, VPN v4 route, right? There will be confusion. So you can't have 2 RD, right, under one verb. But you can have, so basically you can't do this, whatever we want to do, right? Leak route from one customer to another customer. That is not possible only with RD. And that's where route target comes handy, where you can have multiple you can also have 200:200 import here, multiple import or export here, which we will see in next slide. Or so basically you can have flexibility that you can install multiple route targets, right, into same WAF to achieve route leaking from different WAF. That's why we need RD and RT for complex scenarios, right? Is it clear? Any question?
Yeah, Vishal. Just one question.
Yeah.
Okay, suppose for P1, if it is receiving a subnet 10.0.0 with the same RD value, and how would P1 process it?
Okay, can you repeat? P1 receives which subnet?
10 series subnet, because C1B, C1A, if both is having the same RD value, say 10.0.0.0 1.1, instead of a different RD, if it is a conflicting same RD, what would P1, how would it process?
Okay, no, okay, 1 minute. So you mean to say both customer A and B has same RD value?
Yeah, exactly.
Okay. So if that is the case, right, if you configure RD as 1:1 for both customer A and B, so what will happen here? Only there is a problem, right? See, you will not have unique routes. Okay. And because it's only one route, which has two ECMP path, right? Two ECMP path, one is here and one is here, right? You will advertise only one per route. That is 1:1 to 10.1.0.0, 1:1, 10.1.0.0, and then it will be advertised here. Now, how we'll know with this, right, RD value, where to place this, correct? Because now you have combined both the routes. It's same as without RD, right? Without RD, whatever our problem was, it is same, because now you have same RD, correct?
Okay. So it BGP best path selection would select either one of the routes.
Yeah, basically because it's a same route and there are two ECMP path, right? So then it might end up either it will keep in ECMP or it will, but basically our purpose is not solved, right? Because we want to advertise this to this customer and this to this, which will not happen. So basically what happened in this case is, what will happen when if this sends this packet here for this guy, right? It might end up to another guy, right? Because here it's ECMP, right? To both. So that's why basically we need to have separate RD and for each customer.
I think the router shouldn't even allow configuring conflicting RDs.
Yes, that check will possibly will be there in our device. We have to check, but otherwise, yeah, even though it is there or not, but yeah, definitely that does not solve our purpose. Yeah. Okay, any question? Any question? Yeah.
So I just want to know what the behavior would be on our switches when, like, suppose we don't have the requirement of one customer wanting to advertise routes to another customer. In that case, suppose we don't have the route target configuration at all.
No. So see, looking into, so this is again, this is designed, right? RFC, and this is how it should work. Basically, this is all designed, and where it is very much clear based on RFC. So during design time only, they would have discussed all this stuff, right? What if there is a route leak and all that, and based on that, this is what RFC or they have designed, right? And what it is decided is RD will be local, right? Locally significant. That purpose is only to create unique VPN v4 route, and route target is used for import of that route. Okay. So both have separate functionality, and that is how it should work.
Okay, I understand. So if that is not there, routes will not get imported.
Yes. So this is just for our understanding, right? That why they have designed two different RD and RT. What if they have not designed RT and kept only RD, can we have not solved our purpose? We could have, but not for complex scenario. And that's why they have designed, right, as RD and RT separately, and both have different functionality.
Okay, understood.
Yeah. Okay. Any of the other question? Okay. So let's move to some more complex, right? So this is the another one, which is some more complexity, right? So customer A has RD value of this one, right? Which is nothing but AS number plus one random, number. It's combination of that. So 65,100, right? Customer B has 65,200, right? Route distinguisher. And there is one another VRF. So this switch has, or router has 3 VRF: customer A, B, and shared VRF, VRF shared. Okay, which has RD 300. Okay, so 3 different RD. Okay, now what is our requirement? So requirement is it's same. One is this customer A route should only exchange to customer A route, customer B to B. So A to A, B to B. So that's what we are doing here. We are exporting 65,100 here, right, on customer A, and same we are importing at other end, right? So basically 100 to 100 communication works fine. Similarly here also we are exporting 200 and 200 import at other end, right? So basically 200 to 200, 100 to 100 is what we achieve by using this two, right? Is it clear?
Yep.
Okay. Now there is one more requirement. That is what? There are some routes, right? You can consider some of the route of internet routing table, let's say ISP routing table, right? Internet service provider. There are some routes, default route or any other routes, which ISP wants to advertise to both the customer, right? There are some routes which is not the customer A or B route. There are some routes which ISP wants to advertise, or there is, you can consider there is one central site, right, where both customer are communicating, wants to communicate. So basically this site reachability you need to have to both the customer, basically this route, let's say 11.11.0.0/24, right? So you need to receive this route at both the customer, right? So for what you will do, ISP will advertise this route 11.11.0.0, right, with RD of 300 and export route target as 300. Okay, so it will advertise this route, right, across ISP network. Now whether this route will be imported into customer AWF or not, this is advertised here, right? And it is here with this RD 300 and route target X this. Will this be placed into VRF of customer A routing table?
Yes, if we import
It should be.
Yes.
Import, right? We have import, right?
Yeah.
So basically what we are doing here is 2 types of route will be there in customer AWF. One is obviously this route, right, which we received through our route target of 100, right, 65,100. But we have also imported 65,300. So we will also have this route 11.11 into our routing table, VRF table of customer A, right, /24. And similarly, if you check here for customer B also, we are importing this route. So customer B also will have same route installed into its routing table, right? So this is what we were talking about, complex scenario, right? Where you want to receive some of the route which are central site or some internet service provider route, right? ISP route, internet routing table. So that's how you can achieve by using route target, where you can have multiple imports, right? And you can install that routes. Is it clear? Any question?
Clear vision.
Okay. So this is one example, of complex design where you want to leak route from one VRF to another VRF, right? Using this EVPN, right? RT. Now, if we want to check one more complex, right? One more step further, that is this one. So what is this, right? So IP VRF, IP VRF customer A. Let's first check the configuration, right? To understand what is RD 65,100. Fine. RD for this B is 65,200 and VRF shared is 65,300. Okay, three VRF, right? Three RDs. Now, first is you are exporting 65,100, right? And you are also importing the same. So basically, whatever route of customer A from one side to another side, you want to exchange, right? Between these two customer A routes between two sides. Similarly, here we have 200 import and export, right? Export and import. So basically, route of customer B to B also we are exchanging. So that is, this exporting 100, right? We are exporting 100 and that is also imported here. So it's like this, right? One customer end to another customer end. It's and same 200 to 200. One side to another side. Okay. Now next, right? Export 65,000, 1, 2, 3, 4, right? And similarly here. So basically, let's say our requirement is, this is ISP, right? PE device. Our requirement is some of the route of customer A and B. I also want to advertise to ISP. ISP VRF is shared VRF or my central site, right? Let's say central site. Let's take example of again central site, right? So let's go to the previous slide and we'll discuss this and come back here maybe then. Okay, so now this is our site, central site, right? This is my central site, 11.11.0.0/24. Okay. Now, as we discussed, right, that this guy also wants to communicate with this and this also wants to communicate this, and that's how we achieve. We are receiving this route 11.11 to both this side by using this, right? But when reverse traffic comes, you also need to know that there is some subnet, whatever here, right? 10.10.00 and 10.10.11.00, whatever, right? That also should, here also it should learn this routes, right? This guy, this route also 10.10 and 10.11 also should reach here, right? And that's where what you are doing is you are doing this, right? To solve that purpose, what you are doing is that route, right? The 10.10.00 you are exporting with 1, 2, 3, 4. Okay, on customer A. Similarly, customer B also is exporting that 10.11.00, right? Here there is one route 10.11.00 and here 10.10.00, right? 10.10.00 and wants to communicate with 11.11 central site, right? So we are advertising, customer A is advertising this route with export RTS 1, 2, 3, 4. B is advertising this with export RTS 1, 2, 3, 4. Can you tell me whether this route right here, VRF shared is there, where you import this route, right? By using this commands. Can you tell me whether this both route will be installed here or not?
Yes, it will.
It will be installed, right? Because you are importing 1, 2, 3, 4. So that route will be installed in this shared VRF, right? And then you will have the communication. So by doing this, we have solved the purpose, right? Yeah, where we can have customer A and B not only communicate with only A and with its other peer of same customer, but they can also communicate with any other WARF, right? Or centralized WARF. And so this is how, you can make use of RT to achieve route leaking between different sites. Okay, any question? Or if anything is not clear, so let's move back. Let's go back and let me know if you have not understood any of this concept today. RD-RT, right? Why RD and RT both are needed, and any of this concept.
Vishal, one quick
Yeah.
question. So in this VRF customer A and customer B, right?
Mhm.
We are exporting with 65,100 and 65,1234. So is
Yes.
there a so in this case all the routes will be exported twice with two values, right?
Yes.
Okay. Any way we can filter this?
Yeah, actually I also have to check, because when I was going through this right today, I was also thinking, hey, what if I want to, advertise two different routes, or all the routes
Yeah.
here, but some routes here. But I have to check if we have any, route map or anything we can configure.
Okay. Okay.
We can confirm. Oh,
Okay. Okay.
but
Yeah.
also
Okay. So yeah, so basically based on that, we can have control, right? Which route to advertise with which export route target. And that
Yeah.
should be there. Means that without that, there is no point of having this. But yeah, I have never checked that. So
Okay.
thanks, Ajay. Okay, any other question?
Vishal, I have one question. If you can
Yeah.
go to that picture, please.
Yeah.
The previous one.
Yeah. Okay. Yeah.
Actually, when we are putting RD, the prefixes become VPN V4, right?
Yes.
And in our Arista, it is also one, there is a one EVPN global table, right?
Yes.
How we are advertising this EVPN routes from P2 to PN1? Is there we need to activate any address family?
Yes. So that's a good question. So basically, we will activate EVPN address family, right? And so basically what we will do, we will have EVPN to EVPN neighborship. Oh, sorry, not this one, right? Sorry. Let me make it here. Yeah. So let's say we have EVPN routes here, right? Now we want to advertise it to PE1, correct?
Correct.
That is our ultimate goal. So whatever routes we have received, learn here, finally we want to advertise it to PE1 and vice versa, right? Now there are two possibilities. One is I can have EVPN neighborship between PE1 to PE2 directly. Okay. So whatever EVPN routes I have, I will advertise it to PE1 and it will install into its EVPN table, right? And obviously, yeah, for that we have to enable activate EVPN address family. Okay. So that is one. But this is not only two devices, right? There are hundreds of PE devices, right? Like our VTAPs, right? And you can't have, one PE2 neighborship EVPN with all other PE devices, right? That like full mesh.
Right.
So instead of that, what we use is concept of route reflector. Obviously, it is only in IBGP, but otherwise, this is also called route server or route server, basically, right? So basically, what we do is all these PE devices, right? We'll have EVPN neighborship with P devices, right? And they advertise that route to EVPN route to this P devices, and then finally P devices will advertise it to another P device, right? So you don't need to have full mesh. So concept wise, it's same as why route reflector needed, right? With IBGP. Similarly, even for eBGP or EVPN neighborship, you need to have route server or some intermediate device which will have peering from with all the Ps, and then again it will advertise to other Ps. So it's you can consider it as our leaf spine architecture, similar to that, right? So this leaf will advertise to spine and spine will advertise to the other leaf devices, right?
Right.
Yes.
Thanks, Vishal.
Yeah. So yeah. So yeah, and to answer your question, yes, we have to, enable that EVPN address family. Okay. Okay. Any other question? Okay. So now let's go, to the packet capture to understand RD and RT, right? How RD and RT we can check in BGP, right? EVPN, basically update message. So update message, right? IGP attribute AS path, that's fine, right? We are not concerned with that. MP reachability NLRI, right? So this is the multi-protocol reachability NLRI, right? And this is AFI-SAFI, which we already discussed, right? This is the next stop, correct? For all the routes, and then we have NLRI information, all the routes information, right? If we expand this, right, we have different two types of route information, right? MAC in this case. And here, if you see route distinguisher, right, RD value, which is 100. So basically, this is your IP route. You can consider this as a MAC, but it is, let's say this is IP prefix, and you are combining with RD, and combination of this is VPN v4 route, right? So this is where RD will be, right? So each MAC update or IP update, you are adding route distinguisher. So that's how you are making this particular route NLRI as a VPN v4 NLRI, which is nothing but IP prefix or MAC associated with RD. So it's not only IP prefixes are added to RD to make it VPN v4. Even MAC addresses are also, if you are exchanging MAC information for L2 EVPN, we also add that to 100 RD to make it unique MAC for that customer, right? So this is where RD will be there under each of this NLRI routing information. Okay. Now route target, right? So for route target will be into extended community. So there is one more field with MPBGP, which is extended community, right? And if you expand it here, this is where route target also will be there. Route target will be there, right? Which is 100. So basically when you send this update message, you have MP reachability NLRI where you have each route update, right? Which is nothing but RD plus prefix VPN v4 routes, individual each. All of them are pointing to next stop, right? Next stop information. And we also want to send route target with each update message. So this is where it comes in extended community field. Okay. So this is how we can, see RD and RT value combine. Okay. Is it clear? Any question on this?
So the RT value here, it just it implies that we will be importing as well as exporting the route.
Yeah. So this RT value is export RT value. So whenever you are advertising route, we use export RT value, whatever is configured, and that will be placed here. And
Okay.
opposite device will check this RT value, compare this with its own import RT value to decide where in which WAF I have to import this RT route.
Okay. Understood.
Okay. Okay. Any question?
Vishal, I have one.
Yeah.
When we import a route on the receiving PE device, it looks at the RT, and if it matches what's configured under the VRF, it imports that route. Does it look at the RD at all, or the RD is just so we know where it came from?
Yeah. So actually, yes. Let's say this route, right? Let's take example of this particular, right? So we have RD. What was that RD? Yes, 100, right? So we have 100 RD, right? We received, this is receiving router, this update receiving router 100, and then MAC A, right? This is your VPN v4, and you also had receive with route target of 100, correct? So this is the route you received here. Now, when you have to import this, right, there are multiple WAF A, customer A, B, C, right? And you have configuration that for customer A, import route target is 100, right? What does that mean is it will just check the route target, received route. If it is 100, it will be imported under this customer A routing table. It will not check the RD. Okay. It will not check the RD. It will just check the route target is 100, and it will install it here into the customer A routing table. We will discuss maybe in next session that why RD is not needed, because there is possible that for same customer, you might use 2 different RD values, and we'll discuss that in next session, right? And as we told that, right, RD is just locally significant, right? So that's the reason that, you know, you will just install based on RT, not RD.
Yeah, gotcha. Okay.
Okay. Any other question? Okay, then I think, yeah, we are good for today, and I'll upload this session recording. Thank you guys.
Thanks, Vishal.
Thanks, Vishal. Yeah.
Thanks,
Thank you.
Vishal.